Hello and welcome back. Today I'm going to show you how to set up modular parts for real-time characters with interactive physics. This is going to be a long one, but the video will have parts so you can find what you are looking for easily. Hopefully this video will give you an idea how to handle complicated armor physics and apply it to your own armors. This video is not about setting up an armor system, however, inevitably I will touch on it briefly. Now if you're a designer, don't make your life hard as a morning would, meaning you should think ahead before you start creating an armor for a client or a project. Imagination is a great thing, but we should not forget that we have to integrate it to a game at some point, and even if you are not going for game characters, physics should be automated to some degree because you can't just keyframe every single clipping or change in the character, and you should not expect someone else to handle it. Now I deliberately designed the armor in a challenging way so we can touch almost every type of armor behavior you could encounter. Whether it has cloth in it, or a more harder kind of leather, hard surface parts, or with rigid body with dangling parts, that should behave according to the physics. Let's break down quickly the modularity setup which I went with. So it is similar to RPGs or MMO games, so it is broke down to quite a few slots and built in a way to be able to sustain any armor change in every case without extra work. So these are the following slots: head, shoulders with 2 separate slots for left and right, chest, hands, legs, feet, wrists, waist, and 3 unique slots for trinket/collectibles. So let's start with the easiest parts which only require weight paint transfer, and these are the hands, feet, and the chest. Since the base body is already optimized, I will not have to bother with deleting unnecessary weight paints, so this will help me out greatly. For the weight paint transfer, I'm going to use this add-on called Robust Weight Paint Transfer. Link will be in the description. I talked about it in earlier videos. It's a super great free tool if you want fast, accurate results. So the only thing I need to do here is to select the hand armor, base hand as source, with the target armor selected, then hit transfer weights. Then parent it with armature deform. And now if I test it, it works great. Let's do the same on the other hand, parent it, and test it. Same method on the feet armor as well. Just select the original feet as the source, transfer the weights, parent it to the main rig with armature deform, always test it. Okay, hands, feet done. Next, the torso. Even though the chest consists of 2 meshes and the surface one should be hard surface and the below one is an organic one, which is basically the body of the character that turned scorching hot. We are still going to use weight paint transfer, and the target this time is the upper body. For both, I'm going to use the upper body in this case. Let's parent it with armature deform again. Let's test it. Seems good, but a good thing to notice is in some cases it's inevitable a little stretching in hard surfaces, but you can try to limit it with fixing the weight paint manually in a few seconds. Next up is the legs. I have all the parts still separated, where they are still under one material, as the collection suggests. So the legs here are a bit different, because here we are getting some really hard surface that should not stretch at all. Check it in material preview. If you have clipping issues like this, for instance, you don't have to freak out. The basic principle is that, for example, here, the naked lower body will never be visible in a game engine if the leg armor is equipped. So you can consider that it is not even there. In the OG version, only one skeletal mesh is visible in a specific part of the body when we're talking about modular setup. Now with the advanced mutable plugin in Unreal, we can go further. It allows you to hide specific areas completely. You can select the part that's clipping and set it to non-existent, so it won't be processed. It's super useful feature, by the way. So this leg part consists of a fabric, stocks, and a part along with a few straps. So these should behave according to the character's legs. So these are stretchable objects, therefore there we can receive the weight paint transfer from the lower body. However, the calf armors and here the knee pads and the thigh armor should not be able to stretch at all. Now for simplicity and demonstration, I'm going to use the transfer weights on all of them, source the lower body, parent the usual way, and now if I check it, we can see why this will not work on the hard surface. The cloth part seems to get the weight paints just right, so I keep them. However, a few straps probably will need a little tweak. So thinking logically, for the thigh part I would only need one vertex group, and this one is the left thigh. So I'm going to delete all the others. It's basically like parenting to a bone, but Unreal will scream immediately if you don't have a vertex group. So this is the proper way you should do it. Bone parenting only useful in certain scenarios and solely for Blender. So in weight paint mode, I want to change this whole mesh to red. So here at the slider, I'm going to set it to 1. And under weights, I'm going to hit set weight. And now it's fully and only influenced by that one bone. Now same on the other thigh armor. Always test it. Let's see the knee pads again. So some logical thinking. So we only need one vertex group, which will control this, and this will be the calf. Set it to 1. And if you're experiencing something like this, where it's still stretching, make sure you really do left only one vertex group and nothing else influences it. In my case, I left the X mirror on the weight pain mode. That's why the other calf reappeared from nowhere. Now if I test it, it works great. Now one thing we have to keep in mind that I will talk about later, and those are the corrective shape keys, which this will definitely need, and it's actually super easy in this knee part right here. What I'm referring is that we would want the knee pad to stay on the strap, like it's really attached to the strap and not just floating there when the knee bends like this. But more about this later. Let's quickly finish up the others. So the other knee and these calf armors, which should also only receive the calf vertex group. Always test. And here is the issue I talked about, which will require some manual help. First, you should check which bones influences it and make sure only a maximum of 4 bones. So with a little back and forth, you can easily get a way better results. Obviously, as I said, it is important to think ahead. That's why they are placed logically where I will have less job with it. If I would place this exactly at the knee pit, then this would be a really ugly job to do, but it's a bit upper, so it's easier. I prefer to use a smooth often since it just helps with the deformation. And as you can see, the results are quite different now. Let's start cleaning up a bit, so I will remove these new color attributes that the add-on created, and I'm going to hide the completed part temporarily so they don't get in my way. So this is what we left with. Moving on to the head. Now the head, as I mentioned a few times, should have its own rig, especially when we are talking about modularity. So from previous videos, you might know I already have one here, and this one will be parented to the head rig. Now this head consists of 3 parts, one cloth, which is the hoodie, the chain crown, and the head itself. And this chain crown is burned into the skull, so it should have no other influence than the head vertex group, since it should be rigid. I hide my main rig and unhide my head rig. The head should receive a weight paint transfer from the original head, but the horns will probably not receive that, so I will have to paint it. And I'm going to use it as well on the hoodie. Now let's parent these again with armature deform, and I just painted the horns. Other than that, it's untouched. For the crown, I will attach it with an empty weights, and as I said, I will leave just the head and weight it with a value of 1. Now my head rig bones have constraints attached to the main rig, but that's just for practical reasons, so I will only have to manage one rig here in Blender. So if I now test it, it just works. Now the cloth part is a bit different, so in this exact case, I can get away with weight paints on the neck and the head, since this hoodie cannot be taken off, but if the hoodie could be taken off, or even better, dynamically take it on and off, now that's a different story, since in that case you would not have to have weight paint on the neck and the head, but it's a longer topic and I will do a separate video about it. On how much the weight paint will influence the hoodie is also highly dependent on how you will set it up or paint your cloth physics in Unreal. Since mine will be relatively painted fully, it's going to have less effect on it, but I'm going to fix these harsh angles here. Okay, seems it's done. Clean up, hide it and move on. Now let's look at the wrists now. So both wrists have their own chains here, which should move dynamically. For that, we are no longer going to use the original skeleton nor the head rig, but instead we create a custom skeleton that originates from our main skeleton. For that, let's duplicate the whole skeleton and rename it. In edit mode, let's delete everything except the hand and the lower arm on both sides. I will add a bone that will represent the main chain link, and I make sure to include the suffix at the end to represent it's a left one. Place it at the start of the chain. Duplicate it, place this one as well, and rename it. Now I will parent these two to the upper arm. I'm going to extrude both of them individually. Name them as so. And now I'm just going to extrude them along the chain. We'll try to keep them aligned where the chain links meet. If you want to be really accurate, you can go and create bones for each chain link, but this is not necessary at all. We changed this small. Their only purpose is to create some extra visual impact. Now I'm going to select these new bones and I'm going to symmetrize it. That's why we needed the suffix. Now I just need some little bit of tweaking to make it perfect. Now I will go out of edit mode, duplicate the rig and rename it accordingly. Now in these two rigs I'm going to delete the unneeded bones. In the left one I'm going to delete the right-sided bones, and in the right rig I'm going to delete the left bones. I could have just used separate, but I run into some weird problems with that, so I will stick with this method. Now let's parent it with empty groups. In edit mode I'm going to select everything that is not the chain. Then select the bone, then the mesh, go to weight paint mode, and where this face option is selected and the vertex group selected, I'm going to set the whole value of weight to 1. If I select the bone option and with alt click I go through the bones, you can see it's only affected the upper arm vertex group as it should. Now this hand bone will have its function, but just like I said at the knee pads, I will get back to this one as well. The weight paint on this should be 0. Now I select the chain links that should move and leave the main ones out, then hit assign automatic from bones. Now I check with alt if there is any issue, like here. Now I can simply paint it, but I already have an armor part selected in edit mode. Therefore, with face selection, I can instantly remove the paint from it. Like so. Now again, I'm going to use the same method, but this time I'm going to select the main chain link. And where in bone selection, this bone is selected, I switch to face, and I'm going to remove the paint from it totally. Now, same thing on the other side, since I don't want that bone to affect the main chain link. Now with this method, let's give a weight paint value of 1 to the main chain links. Now it still needs some minimal tweak. In these bones, I want them to affect the first moving chain fully. Now I will do that on both sides. And now if I test it, it should work as I wanted. Now obviously you can fine tune the weight paint on the other ones as well, but it's going to be just right. You must be familiar with the wiggle tool, so I'm just going to add some wiggle to this, just for solely Blender demonstration. And now as you can see, it's perfectly working. Now a really important part is that basically almost every asset you export should be exactly in the middle of the world grid center in Blender. So we will need to bring down in a correct way, which I will show you in a second, but first let's do the same exact thing on the other wrist armor as well. Okay, it's done. Now the placement. In edit mode, I select the head of the upper arm bone and place the cursor to it. To make sure everything is alright, I keep an eye on the transform. Now I place the origin to the 3D cursor, the cursor to the world origin, then selection to cursor. Now it's snapped exactly in the middle. Even though the bone is fine, the mesh is off location-wise, and it will cause us trouble. If I just try to apply the transform, it's just going to place the origin far off. If your mesh looking like this is not a good sign and should be fixed. To fix it, go and hit clear and keep transform. So it's no longer parented to the bone. And now I can place the origin to the 3D cursor, or apply all transforms. And now everything is 0 on the axis, which is great. Now with Ctrl P, just reparent it with armature deform. And now both the rig and the mesh share the same origin location. For Blender consistency, we can add a copy transform to the upper arm bone and target our original skeleton corresponding bones. And now I can control it with my main rig. However, for export, obviously you have to turn this off. To make the chains more reactive, here in Blender you can increase the gravity by a great margin. Now I will do the exact same thing with the other one as well. Hide the wrists and let's go to the shoulders next. Now for this again we need to use a similar logic just like before. Duplicate the rig and remove anything except the clavic and the upper arm bones. Create the chains and apply them with the same weight paint logic. Name them and mirror them just like before. And the main chains should be parented to the clavic or shoulder bone. The clavic should be weight painted with 1 and the upper arm with 0. There are a variety of different ways to deal with chains or dangling parts. There is even a paid tool for chains in Unreal for this, but I found that this is the easiest and less taxing way of doing it, and not to mention time efficiency. There is a constraint option in Unreal to deal with chains, but it's not really a great way for dealing with small objects, Not to mention that you would need a child blueprint at best case scenario to be able to handle all the realistic movements, which would cause additional complications where we are trying to maintain consistency. For modularity, we're able to switch between parts, so just write them with bones. So now it's done. Now this has trinkets collectible skulls as well, and this should not be attached to the same mesh, since they should be picked up separately. Obviously, it's just my unique take, that's just an example. I highly doubt someone would encounter with this, but hopefully it will give you an idea. However, not the mesh, but for this new custom rig, I definitely want to attach it, so I'm going to pair them with empty groups. And set the weight of the clavic to 1, and only that. Test it. Now I'm going to set up a copy transform for these as well, for both bones and both rigs. And here now you will understand the knee pads and the hand bone in the wrist as well. So I know that at any locomotion there will be some clipping, because if I lift the upper arm, it's obviously not going to be moving since the weight is 0. However, to only lift the upper arm is quite unnatural, since for realistic effect you want to lift the shoulders as well, at least a little bit, but it doesn't matter how we do it, it's going to clip through anyway. And since it's hard surface, I don't want the weight paint on the upper arm. So what I will do instead is create a few corrective shape keys, which will be based off a fixed axial rotation of the bone. For that I will set up a driver which we can recreate in Unreal with a post-process blueprint, with pose-driven or bone-driven controllers. The problem with weight paint in this case is that we want to limit the stretching as much as we can. And the most probably you will never gonna get the exact results that you are looking for, so it's way more practical to use shape keys. However, I want to edit 2 shape keys at once because of the trinket. I could technically join them, then later separate them to avoid this method, but I just wanted to show you that you can edit 2 shape keys at once on 2 different meshes, or multiple meshes. So it's pretty simple, just add the base on both of them, then add a key and set it to 1 on both. Select both, then start editing. This way it will register whatever I change on both meshes. The key is to create the most realistic look on the shoulder in this pose while maintaining their portions as best as we can. Save whatever you think it's starting to look good, because if you mess it up you have to delete the shape key and start again. Just use proportional editing with really gentle touches. As you can see, both is working fine. I will rename it and add the driver to it. Leave it on scripted, then select the shoulder armor rig, then select the upper arm bone, then set the rotation to Y and select local. And you can use a script for rotational drivers. I will leave this in the description for copy and paste. Now just copy this driver and paste it on the skull shape key as well. Test it. Seems good. We need at least 2 more. One when the arm is backwards and one when the arm is in front. Use exact numbers when rotating, like -90, like I did. Now you have to do the same exact method like before, so I'm going to skip past that. So now I have created all the shape keys on both sides, and this is how, for example, the forward one looks. Let's copy the same driver function and just replace them with the used rotation. In this case, -90. And set the rotation to Z. Copy the driver to the other side as well, for the trinkets as well. Let's do the backward one as well, it's just simply 90 degrees on the Z-axis. Copy and paste again to the other side. Now in the right side, just change the rig and the bone name to match the right rig. If I just test it now individually, it's just working great. I will remove the constraints from the bone and we'll do the same exact origin placement like at the wrist. This step is really important, so don't skip this. Now once that's done, I just place back the constraints and it's working again. And now you know why I mentioned the knee pads. It's pretty simple, because you only need 1 rotation, and it's basically a few seconds job, since normally knee should bend only one way. Same thing with the hand bone that I left, you can create an extra rotational shape keys to avoid any clipping. Now the last part is the skirt part. Now this is the most complex because it has hard surface and the cloth leather and chains, and the most problematic area, the pelvis. And unfortunately this time, especially in an all-fold design like this, You can't avoid some extremely annoying heavy weight painting. You can help yourself with some additional helper bones to make it easier, but it's still going to be tough. Now this time I would need to visualize the things, therefore I'm going to retarget the main running sequence of the character. If you have your own running, you should use it. We'll try to weight paint the belt. Or a motion sequence where the thighs and pelvis animated in a variety of highly dynamic poses. I just set the range for the full loop. And it's good for other visuals as well. As you can see, I accidentally left in the boobies vertex paint on the hard surface, which I will just simply delete right now, since only the inner part should recite jiggle physics. And now it's looking much better. Let's duplicate the rig again and delete the upper part while leaving a few bones above the pelvis. Let's first use a simple transfer weights and then parent it to the armature deform as usual to use it as a base. You can see out of the box it works kinda right, but the hard surface parts are actually stretching. Before I fix that, I'm going to create extra bones for the skirt part with basically the same method as I did with the chains and parent the main controlling ones to the pelvis. Now we can do the automatic weights for these bones, but it's not going to give me the results I need. But I also definitely don't need any weights on these parts, on the lower bones, so I can simply set them to 0 or delete them. In rare cases like that, it's better to separate the object to different parts and paint them separately, since they need to have different behaviors and it's just an easier way to fine-tune it. Now I'm going to speed up the process since it will take a while. And this is the final result. You should get something like this, which is relatively close on how this should behave. Now you can see the problem starts here because the skull parts clip into the waist, and here both the cloth and the chains and those little skulls, those brooches, fully clip through the legs. And this is what we need to fix. Now that's a major issue, and there are a variety of ways to handle it, and we not just have to think in Blender, we have to think it how we can solve it in Unreal or any game engine of your choice. Because in Blender it can be done relatively easy, I should say, since what we need to do is to make the skirt part cloth, then paint the vertex group, then add the simple constraint to the rigid hard surface mesh. Then it will precisely stick to it all times during the animation. And if you would hit it with a collision object, it should still remain in the same position. Now you might think, well, then it must be easy for a powerful game engine like Unreal, but oh boy, it's definitely not. Since Blender Cloth Simulation and Unreal Cloth Sim works totally differently, therefore it's way harder to make it precise, and I myself is too dumb currently to make it work properly. To achieve this exact result, what you would need is to get the exact vertex position of the simulated cloth, which can be done through C++ or Niagara Dynamics. And after looking through the nodes in the new cloth asset creator, I believe it can be done somehow through that, but with my current knowledge, I am unable to make it work. If anyone is aware of such things, please let me know in the comment section. I would highly appreciate it. And that is probably the main reason why you not see such design. If you're looking through on Fab or anywhere, you won't see hard surface directly on cloth, like brooches. You only see that on places where the character will not bend. Therefore, it's cheated in a way that they don't have to bother with it. And you especially will not see in places like this extreme. So therefore we need to use a workaround, but first let me show you the weight paints because it should be done prior to any shape key manipulation. So these are all the weight paints that I did for the bones. I could have added a few bones to the side chains to make them dynamic, but in my original design they are meant to stay rigid. If you want them to move, about 3 bones per side should work. Also make sure the chain ends use gradient weight painting. Using hard weights can cause them to disconnect from the surface. Now you will need a main skull part to move the way a bit, and the chains to be on the leg as well as the mini skulls when the leg rotates in front. So I will create a shape key and yet again separate them to different parts to make my life easier. And again, with proportional editing, just try to not distort the hard surface too much. With the cloth part must be obviously stretched. Now once it's done, again the same shape key driver method is used here again. And as you can see, it's looking way more realistic this way. If I rotate the legs to a certain amount, it will activate this shape key. I will do 3 more, so 1 for the front and 2 for the back. And now I can even add wiggle to these bones. And this is what we can expect approximately in Unreal. The jump you see is because I keyed the first frame in a rest pose to make my life easier, by the way. You can see the skull is in front, like it's just pushed away by the leg and not stretching with the leg anymore. Now when we are exporting, make sure on frame 0 everything is keyed in rest pose, otherwise, yes, Unreal will whine again. And this is the exception because right here I don't want this to be in the world grid center, and I will export it out as is. Now I will also show you another method, how this can be handled, and therefore I will export another version of this waist armor, where the skirt and the hard surface are separated. Since you can't use morph targets and cloth simulation at the same time. However, as I read it, it might be possible now in Unreal 5.6, but I didn't test it yet, so I can't really give you an advice on it. For this separated version, I will need to remove the shape keys from the skirt. Export everything, and see you in Unreal. So here I have all my armor nicely organized in folders. Here I have my modular character set it up. If you are not sure how to set it up, there is a video that I have that will help you guide you through it. So I have the lower body, feet, upper body, hand, the head, with child skeletal mesh components. And this is how the construction script looks like. The first thing you should do is go to the project settings and under engine look for a collision. Create an object and trace channel. I already created them. This will allow us to use unique collision without interfering with other engine standard collision presets and will avoid any crashing later during the development. As you can see, the object collision name is armor and the default response is to block it. This is how you can create one, and same with the preset. Now here you have to give a name, style of the collision, which should be collision enabled, quarry and physics. Object type should be the new one you created, and you have to give a description to it. It doesn't matter what it is. This is the setup. Basically it ignores everything except pawns, which basically is our character. And currently it's only on the lower leg, the driving mesh. Also the capsule is the only one that should ignore the armor. Now let's start adding those armors. Go on the skeletal mesh, make sure it's the child of the lower body. This will be the leg armor. Add the skeletal mesh. Now it's obviously not going to follow the armature right away, since it doesn't have a blueprint. Let's add it to the leader pose. And after compile, it perfectly attaching it. I turn off visibility. And at the event graph, I start setting up some extremely basic visibility toggling just for demonstration. I get a set visibility, and just for test, I plug in these two. And in gameplay, if I hit 3, I can make it visible, but I didn't set the logic for turning it on again. So let's see it with toggle visibility node instead of set visibility. Now I can easily set it visible and invisible with one button. Now let's plug in the lower body and see what happens. As you can see, something weird is happening. So since the lower body is no longer visible, there is nothing to drive the animation on the other parts. So that's not going to be good, but if I press the button again, it's working again. So back in the event graph, look for set skeletal mesh asset. Plug in the lower body, and for the new mesh, get the leg armor. From that, get a set material and get the legs armor material. And for target, use the lower body again, compile. And now if I test it, the animation no longer stops, since here there is an actual identical skeletal mesh driving the animation now. Now we get a flip-flop to be able to switch back and forth. Select this, duplicate it, get the lower body as new mesh, lower body as the material, plug it into the B, compile. Now we can toggle it on and off. For the other parts, we will be able to use simple toggle visibility. This is the only part where it should be set it up like this. Now let's add the child skeletal to the feet armor as well. Get your armor and use it in the construction script. Here in the event graph, let's duplicate this, set a different key binding, get a toggle visibility for the feet armor, turn off visibility on the feet armor, get the base feet and plug it into toggle visibility. Connect it up, compile and test it. Seems good, moving on. Let's add the hands, same exact thing, like just at the feet. Add another one to the upper body, this will be the chest armor. Again, same thing. Turn off visibility on them and set up the toggle visibility just like before. Test it. Okay, cool. Next one is the head. So add the skeletal mesh to the head. Now this one will be different. I don't want it to be part of the construction script. What I want is a post-process blueprint instead to drive the skeletal mesh. I can look for a post-process, and as you can see, I already have the main animation blueprint for the head and the copy pose from head as well. Now this is extremely easy blueprint, it just constrains a copy pose from mesh, which you can do by right-clicking on your head skeletal mesh and create an animation blueprint. Inside you can see there is nothing else, only one node is plugged in, with all these three ticked in. Now I save the skeletal mesh, and as you can see, it's right where it's supposed to be. Again, I can create a toggle system, and I also want to remove the hair as well, turn off visibility, and it's working fine. But let's add some actual cloth simulation now. Right click on the skeletal mesh, create a clothing data, and I want to select my upper body, since it's properly set it up. Now this is kind of weird to set up, because if I'm now going into cloth paint mode, I can't really paint it without interfering the head mesh. I can try to use fill and work from there, but I can't fill the main one with 0, only parts of it. And if you want fine-tuning, this can be really annoying. So instead of suffering with that, like this, I'm going to delete it and show you another method. For that, let's hop back to Blender quickly. So I want to join the head mesh and the crown together, and leave the hoodie out. Now I will duplicate the hoodie mesh and call it Hoodie Proxy. This will be the mesh that will drive the cloth simulation. Since this is a proxy, I can add a subdivision to it as well. I use only one subdivide with a simple set it on, then apply it. Now select all three and the rig, then export it. Now in the head armor mesh, I will now re-import it with a different file. Once you've done it, you probably will see that nothing has changed, and that's because they are still one single mesh. Now click on the re-import mesh with dialog, and look for this, keep section separate. Tick it in. Now you can see that I have three materials here. So now we can highlight each to see they are indeed imported separately. To determine which one is the high-res mesh, you can go to wireframe. So the last one is the high-res mesh, so this is what I want. Now right-click on it, create clothing data. Again, I select the upper body, and then I tick in remove from mesh. This will remove this exact mesh from the whole skeletal mesh, and it will only drive the animation. Let's hit create. And now if I isolate it, you can see there is nothing left here. And I left with the two meshes instead. And now if I activate cloth paint, I got a much easier job, as you can see. However, I will still use fill and use it with a really low value like 0.5. By the way, the fill value means how many centimeters can the cloth travel from its original position. With the brush, I'm going to paint the back side of the hoodie with 5. That seems reasonable, and paint the front area with about 2. Exit from cloth paint, right click on the hoodie and apply clothing data. Okay, not so bad, but it needs some fixes, but as you can see, it was way easier. Now the cost of this laziness is one extra draw call, because now this mesh will use 2 material slots instead of 1. Oh, and if you experience this, it's because the obviously has to use the same material. So I'm going to switch that to the right material. And now it's all good. You can remove the last material and rename this for clarity. Now let's do some fix. Just set the local damping to 0.01. And definitely add some onion drive stiffness as well. And increase the gravity as well to make it heavier. Now let's paint the edge here with a value of 1 instead of 2, and smooth it out maybe 1 time. And now it's looking way better. Let's test it. Seems it's working just fine. Well, at least on the upper body for sure, but how about if I switch to the armor? Well, not so great anymore, it's clipping through, and it's clipping through because cloth simulation currently only using the upper body physical asset, and it will always use that unless we tell them to change it. So let's fix it now. In the event graph, get the chest and upper body toggle logic, and let's get a flip-flop. From the chest armor, get a set visibility, same for the upper body. Delete the toggle ones, tick in new visibility for the chest armor, and plug them in like so. Make the same for the B socket as well, but tick in new visibility for the upper body this time. Test it. Cool, it's working. Let's open the chest physical asset and the upper body physical asset. As you can see, they're almost identical. Now for demonstration, I'm going to place this one way off, save it. In the event graph, create some space and get the head armor mesh. From that, get a remove cloth collision source. In source asset, select the upper body physical asset, get the upper body and plug it into the source component. Plug it in, get the head armor, from that look for an odd cloth collision source, select the chest armor physical asset, and get the chest armor in the source component. Connect them up like so, duplicate these two, unplug these, and this time get the armor physical asset here, and plug it in the chest armor. Here select the upper body, and connect it up like so. Compile, and let's test it. And now you can see we are getting some reaction. But what you can notice is that it only updates the collision if I move a tiny bit. Now that's not a huge issue, but we still want it to be more dynamic than this, and we want an immediate response. For that, select your head armor and look for force, and tick in force collision update. Compile, and now we got the perfect reacting hoodie. From now on, it's only the matter of setting up your physical asset right. Now there's a slight issue here, which comes from my painting. This part should not be affected by cloth simulation, so I'm going to fix that. And now it's working great. Moving on, let's add 2 skeletal meshes to the upper body for the wrist. Select the mesh, and you can see they are exactly at the middle as they should. Now just to show you, you can brute force your way with sockets as well. I already prepared one. If you are unfamiliar with it, you can just add a socket to any bone to serve as an attachment point. And you can add the previous mesh. Then rotate it like so. But I'm not going to use this method, since I want it to be 100% accurate. So for that, let's create an animation blueprint for the wrist. Get a copy pose from mesh, plug it in, and tick in this. Save. Then add it to your mesh. Save. Now you can see something is happening, but it's still not in the right place. How about if I select the lower arm, which is the root bone basically? As you can see, it's still off. This should be up here. How about if I select the upper arm? And look at that, it's a 100% match. Now the chains are still rigid, so let's fix that. For that you need to make your physical asset like so. I already made it and it's pretty easy. If I select the constraints, you can see they share the same logic. Just to show you how to do it, I'm going to create another physical asset now. So this is what you probably would see if you first open it. Let's adjust this capsules a bit. Click show all bones. Select all chain bones, right click and replace bodies. And now we have all the shapes and constraints. Set it up for us. Select all the chains, box select the constraints, and limit the angular movements. And use values similar to this, or test out what works for you best. Next, select the chain link bones that should move, and set them to simulated. Select the chain links that should not move, and set them to kinematic. And that's it. You can play with the values of linear and angular damping as well as with the mass itself. In reality, the mass should decrease from top to bottom. I will just delete this extra physical asset since I already have the same exact thing. In the blueprint, get a rigid body node and use the following options. These options are responsible for how much energy they get from the source driving component, which is basically the main rig. Connect it up like so. You can press Q to straighten things out. Here in the preview you won't see anything because currently we are copying from a different mesh. To see it working, you can use an input pose for testing. Now let's connect this back up again and test it. And it seems it's working as it should. Let's do the same exact thing on the other one now. Something is wrong here. If you see this, there is something definitely wrong with the origin or with the skeleton. Let's check the skeleton. And I can immediately see that the lower arm has a different name than the original rig head, so there is a 001 there. The bone name have to match exactly. Now with the editing tools you can quickly fix that here, and I can reassure you it's working like this as well, but whenever I get these messages like this, I don't really like to risk, even though I know it will work. And I like consistency, so I'm just going to simply change it back in Blender. I just rename it in edit mode and export it as usual. I create another folder because if I re-import, it will give me a hierarchy error, which I really don't want. Don't bother this warning, it just can't handle the emission. I'm going to switch to my original material, delete this new one, set up my physical asset again and use the new one. Delete the old one and I will have to remove them from places that has references. Jump ahead and now we can see both of them working just fine. I set up the visibility again, moving on with 2 new skeletal meshes to the upper body for the shoulders. Always make sure they are at the center at the right place. Now same exact thing on the physical asset, just like at the wrist, so I'm not going to go through that again. But now we have the shape keys here as well. I place the skull with the sockets here so you can see the problem, and it's obvious the socket will not going to follow the morph target. That's why we need the morph targets on it as well. Now let's create an animation blueprint. Usual copy pose from mesh. Now tick all 3 in. Apply it to the mesh. And now we can use the same method just like at the wrist, but this time use the spine 5 or whatever your shoulder bone parented. It's working as well, but I'm going to show you a different, still accurate method. Instead of this, in the blueprint, if you tick in mesh pose, it's going to achieve the same exact thing. Now make the chains move with the same rigid body logic, just like before. Input pose for check. Okay, good. Now connect it back, compile and test. Alright, working. Same thing on the other one. Super. Now back to the shape keys, aka morphs. You have to have curves on your shoulder skeleton that represent these morphs. I already created them. Their name need to be exactly the same as the shape key, and they should be set to morph target. If you're not sure how to create one, click on this, write in the name and check in the type, and that's it. It's extremely important, otherwise it will not work. Get a bone-driven controller node. At the source bone, select the upper arm and set the rotation. Destination mode morph target. Copy the shape key name and paste it here. You can use driving curve as well. I talked about it in my other videos, or you can just simply use remap morph target. Source range should be the same you set in Blender, in this case -90, mapping range 0 between 1. Connect it up and use the input pose for test. Okay, compile, find the upper arm and rotate it. And as you can see, it does what it should. Okay, copy the node, copy the other shape key, rotational axis remain the same, change the rotation to +90. Connect, compile, test. Last one, copy the shape key, paste it. Now change the rotation to Y. Change the range that matches the Blender one. Compile and test. Okay, nice. Now plug back in the copy pose, compile and test. Now you can see the difference and why we needed that. The right one is clipping through, while the other one, the left one, is perfectly working. As you can see, it's working fine as jumping as well. Do the same one on the right side now. Just copy the nodes and change the bone and shape key names and test it. Now let's add those collectibles to the equation. Let's add 3 skeletal meshes to the driving mesh, which will be the lower body for me. I will apply the meshes, compile. So even though they are different skeletal meshes, I imported them according to their shoulder skeleton. So they are share the same skeleton as the shoulders. So the shoulder skeleton has to contain the curves for this trinket morph target. As you can see, all 3 are here. And we don't want to add them here, then apply it to the skull, because that's kind of an overload and with some pointless calculations. So therefore we will create a separate blueprint for the skull as well. Copy pose from mesh as usual, tick in all these, and as you can see, it's right where it should be. However, if we move, obviously the skull offsetting when the morph targets trigger. That's the reason we need the morph targets on them as well. Setup is fairly simple, copy and paste, and just simply replace the shape key names and connect them up, and compile, and test it. And now it moves with it correctly. Same exact thing on the other rig, however we can make just one blueprint for these 2 trinkets / skeletons. Add them to the skeletal meshes, and now we have no clipping issues. Nice. Set up the usual visibility trigger. Now for the bed, let's add it to the lower body. So as I said, there is 2 versions I will show you, a combined one and a separated one. This is the normal combined one, so let's start with that. You guessed it, we start with an animation blueprint. Copy pose and apply to mesh. Get a bone-driven controller and set it up just like at the shoulders. Again, make sure your skeleton has the morph targets as curves here. Tie rotation on the Z by -90. If you're not sure about the rotation, you can check it in your main mesh. Use input pose for testing. If I rotate the thigh bone, it should work. Set up the rest like so. Test it. If looks good, plug back in the copy pose from mesh and test again. Seems almost perfect. Now in the physical asset for the skirt bones, let's add and replace bodies. And they are kind of all over the place, and I don't even want to use capsules, I want cubes instead. So select all the skirt parts again and add box. Then I'm going to delete the capsules now. Let's add the rigid body node like so. Select all the skirt parts that should move and set them simulated. Save it, compile. But that's kind of weird. Let's fix the limits by selecting all the skirt constraints and use some similar values. Save it and test it. Yep, it's looking way better. As I said, if it receives too much momentum, you can decrease or tweak these values. Also, I'm going to add my jiggle node to the mix here. It's not necessary, but it enhances the look. And copy the constraints from my jiggle settings and paste it over here. Save it and test it. If everything seems good, but you get the tiny flicker, you can simply try to adjust the size instead of messing up your whole setup. If I set this to a really low, it should not make a huge difference. I will try it with 0.5. And it seems that solved that little clipping. However, it's still not done, obviously, because it's going through the legs. To visualize what colliders we are having, press F8 and look for collision. It seems only the lower body collision is there and the capsule. That's because everything else is currently set to no collision inside the third-person blueprint. So let's change that. So here at the waist, look for a collision and set the preset we created in the beginning. Now it applied the same settings, so it's blocking only the pawn. And this pawn object is blocking the armor. Now if I compile, we should see that it is colliding with the mesh properly. And if I press F8 again, then we can see that the colliders are right there as they should. But this jiggle one is jittering, so let's solve that. I'm just going to set these to default and check it. Now they are all good. Now it's just a matter of adjusting the proportions of the collider shapes properly to align with the mesh. Let's test it. Okay, that seems fairly good to me. Maybe too much momentum, so I'm just going to tweak that. Shape key working fine. No clipping issues, seems right to me. And basically you can do the exact same thing on the chains up here as well to avoid clipping through. Set the upper body to pawn and set these to armor. Compile, and now we should see the colliders. However, these small objects will probably still find a way to clip a bit. However, majority of the time they will block as they should. You can try it with force collision update, or even better results, you might need to enable CCD as well. But it's just an overkill, in my opinion. Now for the separated version. So physical asset has nothing extra. For the belt, I can just use the same blueprint like before, but I don't need a rigid body or the spring bone. For the skirt, however, we need to create a clothing. You can use the same method as I showed you at the hoodie, but I'm just going in raw here. For the asset, I'm going to select the simple lower body. For paint, I'm going to use the volume of 100 as 1 meter basically. Let's apply the clothing. Now drive stiffness is a must. Density to 0.5. Bending stiffness to 0.85. Area stiffness. Tether stiffness. And some friction. Some more drag. Lift as well. Maybe check with the lower drive stiffness first with some damping. By the way, don't think I pulled this out of my ass. There is a documentation on how cloth should be set it up. However, they are not quite right, even though it's from official EU sample. Anyway, let's add a mask with this and set the target to drive stiffness. On its own, it does nothing. We have to paint something here as well. So this mask is the stiffness mask. We'll determine how much stiff, or more like how rigid the cloth will be in certain places. So for example, here we have a hard surface. I want it to be full stiff. I can change this from 100 to 80 to 10. It doesn't really going to make a difference, and I'm going to tell you why in a few seconds. Let's change this now to a simple belt and add the skeletal mesh to the waist as a skirt. Create a simple copy post from mesh to the skirt. Apply it to the mesh, test it, and now we can see it's horrible. Let's reset this just in case. In the original mask, I'm going to paint this part with 50, so it can only travel a maximum of 50 centimeters. Give this anim stiffness 0.1 again. Okay, it's better, but still weird twisting. Let's paint this upper part a bit. Okay, it's not clipping up here. Let's give some more density. We can use self-collision spheres as well. We can tick in smooth transition as well. Okay, so this unidrive stiffness mask is working a bit weird. So in a logical world where everything is intuitive, there should be a restriction here at the paint value. So you could only choose between 0.1 and 1 value. Because in reality, these are the only options here. 180 and any other number simply equals 1. Whatever you set in the driving stiffness for low and high, that will determine the paint value as well. So currently I set the unidrive stiffness to 0.1 in the config. That means I give the whole thing a little bit of stiffness. So that is the base basically. If I set the low value to 1, then that would mean the whole skirt would be fully rigid and not move at all. So with that logic, let's paint it. So I want the bottom part to equal 0.1, meaning the base of the whole stiffness. So it should move totally freely. Now let's change it to 0.2, since I want it to get stiffer and stiffer as I move up. Okay, 0.3 now. And 0.4. And now let's test it. Now it's acting quite nice. And we can see everything working underneath as well. I create a toggle for this as well. And this is the final form. So thank you very much for staying with me in this long journey. I really hope this video helped you out and give you an idea how to handle complicated or complex armor physics inside the game. If you did, please leave a like, subscribe, and if you have any questions, please let me know in the comments below. Thanks for watching and see you guys in the next one.